All right. Good morning, guys. How are you?
Good morning.
Good morning.
Good morning.
Huh?
Priyanshi, did you take the test
Good morning,
again?
Professor. Yes, I did. Thank you so much.
You're welcome. You're welcome. All right.
Thank you so much.
All right. Okay. Good. So I hope you're all doing well. So I basically imported your test mark to Blackboard. Most of you guys, except you, Priyanshi, because I did that a few days ago. I think your mark is still in Vereta. So, but the rest of you guys, I think you can see your mark in Blackboard as well. So that's what I want to would like to tell you guys, and also it's good. So most of you guys did pretty good. The people who did not do well, I sent them an email telling them that you need to basically work on the rest of the course. Okay, so that's important. If you didn't do well at the beginning for test one, don't give up. You still have hope. You can still basically do the rest of the test good, and then you can pass this course. Okay, just keep working hard, and then you can do that. Okay. Any question before we start the lecture today? All right, no question. We can start. Look like we are missing some people, but I hope they show up later. Okay. I'm just going to share my screen. All right, so today we are discussing, so you see my screen, right? So you can see my screen, right? So the PowerPoint?
Yes.
Yeah, all right.
Yeah.
All right, so today we're gonna start the new concept called annuity. So what are annuity type, notation and type of annuity? So an annuity is a series of payment, usually is in equal amounts made at regular interval of time. Okay. For example, if you have a car lease payment. Okay, so you have a car payment. You buy a car. You're paying. For example, for my car, I pay like $300, $400 a month. So I pay $400 a month for 2 years. Okay, for my car. My car is a second-hand car, so I do that. So I'm sure you guys have some other car payments or lease payments, something like that. So the annuity is basically when you pay $400 a month for a specific basically time interval, it's called annuity. Okay, so that's what's called annuity. For another example is mortgage payment, right? So you pay like I don't know, $2,500 a month for mortgage payment, and for certain period of time, it can be like 25 years. Okay, so that's also called annuity. So annuity is any kind of fixed payment over a specific part of time and in the regular time. Okay, in a regular time interval called annuity. So can be monthly, can be weekly, can be even daily, can be semi-monthly, can be different. Payment can be different. Basically, period of time can be different, and also the basically the total time can be different as well. Okay, so that's called annuity. So what are important notation in annuity? So these are important notations. T is the term of annuity, like the total time, can be 2 years, 3 years, 5 years, 10 years, 20 years, 25 years, 30 years. PMT is the amount of the periodic payment of an annuity. Okay, so PMT is the amount, like $400, $500, $600, $1,000, $2,000. That's it. That's the amount of periodic payment of an annuity. Okay. N is the total number of payment during the term of annuity. So N is basically the total number of payment. For example, if you, for my case, I have a car for 2 years and I'm paying monthly $400, right? So for 2 years, $400. For 2 years, and I'm paying monthly means I have to pay $24 24 payments. Okay, so N is the total number of payments. Okay, during the term of annuity. J is the nominal interest rate. So, for example, for my car, I pay like 8% nominal interest rate on my car. So, is nominal interest rate for the payment. M is the compounding frequency, a number of compounding periods per year. So M is the same concept as MB had for regular investment. That is compounding frequency. I is the periodic interest rate, the same concept as we had in that's the same concept that we had with basically regular investment. Payment interval is a time between two successive payments, right? For my case, it's monthly, right? So payment interval for my car is monthly, right? So monthly payment. So it's a time between two successive payments, okay? Payment interval, okay? FV is the future value, is the accumulated value of future value of annuity. So for example, I will discuss this later, okay? Future value of annuity. PV is discounted value or present value of annuity, okay? I will discuss these two concepts later, okay? So this is future value and this is present value. So these are notation which you need to remember, okay? For example, if I pay the payment, if I pay the payment every day, the number of payments per year is going to be 365. So there are a couple of other stuff, right? So we learn daily, we learn monthly, we learn quarterly, semi-annually, and annually, right? The compounding interest rate generally are daily, daily, monthly, quarterly, semi-annually, and annually. We learned this before, right? And we know the compounding frequency for daily is going to be 365. We know the compounding frequency for monthly is 12, quarterly is 4, semi-annually 2, and annually 1. Okay, three other things which you need to add to your basically payment interval or compounding frequency is weekly, bi-weekly, and semi-monthly. These are also the kind of payment which you can add in the annuity. So the weekly you will have compounding frequency of 52 because we have 52 weeks in a year. Bi-weekly you have 26 compounding frequency because you have 26 bi-weekly in a year, and semi-monthly is 24. Okay, because it's half a month. Okay, so then 24 half a month is going to be a year. Okay, so these are the compounding frequency or number of payments per year which you have to do for this kind of payments. Okay, this kind of payment on the left. Okay, any question? All right. Okay, so now let's solve an example. Calculate the number of payments and during the term of the annuity. You deposit $200 at the end of every 3 months for 5 years. So calculate the total number of payment. Okay, total number of payment in this case is, so every 3 months for 5 years, right? So means that you have payment interval of 3 months, and the number of payments in 1 year is going to be 4, right? So it's because you have 12 months divided by 3 months is going to be 4, or you can, the other thing which you can say is that this is quarterly, so the compounding frequency is going to be 4, right? And then N, which is total number of payments, is going to be compounding frequency multiplied by number of year, which is 5. It's going to be 20 payments, okay, in 5 years. So 20 is going to be N. It's very similar to regular investment. If you remember, future value is equal to present value 1 plus I power of N. That's the same N, basically. That's the same N. So the N is calculated the same way. So you have, you multiply compounding frequency by the number of years, okay? That's how you calculate the N in annuity as well. So the structure is going to be the same, but you're probably going to have daily or maybe weekly or bi-weekly or semi-monthly in there, which you learn already. How do you what's the compounding frequency for these guys is, right? So compounding frequency for weekly is 52, compounding frequency for bi-weekly is 26, semi-monthly is 24. Okay, but the structure of finding N is going to be very similar to regular investment. Okay, so N is going to be, in this case, because it's 3 months and you do it for 5 years, so it's going to be 5 multiplied by 4, right? So 4 payments per year, because you have every 3 months you you deposit every 3 months. So for 1 year, you're gonna have 4 payment and 20 payment for total payments. Okay. Another example, you deposit 1,050 at end of 6 months, at the end of every 6 months for 4 years and 6 months. So what's going to be the end? So 6 months, you have 2 deposits in 1 year, and they are 4 year and a half. Okay, so 4 year and a half multiplied by 2 is going to be 9. Okay, so you have 9 total payment for 4 years and 6 months. You receive $500 at the end of every month for first 2 years, and thereafter 800 at the end of every month for the next 4 years. What's the end? Okay, so in this case you have two problem, right? So one, 2 years every month for 500, and then another one 4 years every month for 800. So you have two different n, and then the total n is going to be sum of this n with the other n. Okay, so you have 2n. So first n is going to be the first one, every month for first 2 years. So you have 12 months a year multiplied by 2, right? So basically the entire same, okay, so it's 2, so it's going to be 2 years multiplied by 12, right? So for the first one, so compounding frequency is 12 multiplied by 2, it's going to be 24 for the first part, right? First annuity. And for second annuity, so we have 2 different annuity here, right? So we have one annuity is constructed for first 2 years, and second annuity constructed for the next 4 years. Okay, so first annuity we will have 2 multiplied by 12, the compounding frequency, which is going to be 24 payment, and for second annuity we have basically 12 compounding frequency, again the same compounding frequency, right? Every month again, multiplied by 4, which is 4 years. Okay, so we have 48 payments. Okay, so we have 2 different n, and then the total n is going to be summation of 24 by 48, which is going to be 72. Okay, so that's total number of payments. Okay, so this is 2 different annuities. Just make sure when you are still monthly, but the deposit change. Then the deposit change means that you have different annuity. Make sure, take a note of this. Okay, so is not one annuity. This is very important. 6 years, but this is not one annuity because the payment changed. It's 500 and then 800. It's very important to remember. Okay. Okay. So what's the type of annuity? Okay. So we have ordinary annuity, which is basically the payments. The payments are at the end of each month, at the end of each period. Okay. So when we have ordinary annuity, means that payments are done at the end of each period. So in the first month, and the second month, and the third month, until the last month. Okay, that's ordinary annuity. But we have also another type of annuity we call due annuity. Due annuity, the payments are done at the beginning of each month. Okay, at the beginning of each month, you pay the payments. Okay. And the last month you don't pay anything because you already paid at the beginning of the month. Okay, so there are 2 types of annuities: ordinary and due annuity. Ordinary, as I said, is just the payment done at the end of each period, and due annuity is done at the beginning of each period. Okay. Also, there are 2 other types of annuity as well. So this is 2 in terms of payment. There are two different types: ordinary and due annuity. And in terms of interest and compounding period, also there are 2 different types. Okay, if the compounding period for interest rate is equal to your basically monthly payment, in the regular payment, like payment period, then it's going to be simple annuity. Okay, so simple annuity, for example, I'm paying my car loan every month, and my interest rate is compounded monthly. Okay, if my interest rate compounded monthly and I'm paying the loan every month, means that my annuity is simple. Okay, So simple annuity, your nominal interest rate compounding period is equal to payment period. Okay, so payment period is equal to the compounding period for interest rate. Okay, and if it's not the same, then it's called general annuity. For example, your compounding period is quarterly, but you're paying monthly. Okay, so if you pay monthly, but your compounding period for interest rate is quarterly, then your annuity is going to be general. Okay, so okay, if we want to summarize the whole thing, we have annuity. So we have ordinary annuity, which payment are done at the end of each payment period. And then for this ordinary annuity, we can have simple annuity or general annuity. Simple annuity means that your compounding period is equal to the payment period. Okay. So in this lecture, this lecture this week, we only discuss the ordinary simple annuities, and we saw some example for this. Okay. And we'll leave the rest of these three other guys for the next week. Okay. So ordinary simple means you're paying at the end of each period, and your compounding frequency. Your interest rate compounding period is equal to your payment period. So your payment period is equal to compounding period for your interest rate. Okay. Ordinary general, you're still paying at the end of each payment period, but compounding period is different than the payment period. Due annuity. So due annuity, simple due annuity is basically your compounding period and payment period are the same because it's simple. But your payment are at the beginning of each payment period. Okay, so at the beginning of each payment period, you do the payment, but and also the compounding period for your interest rate is equal to payment period. Okay, and general due annuity is basically your compounding period and payment period are different, and your payment are basically paid at the beginning of each payment period. Okay, so there are 4 different kinds of annuity, but their equations are very similar. But you need to just memorize this, and then this week we only discuss ordinary simple annuity. Okay, so this week we only discuss the annuity which the payments are done at the end of each compounding period. Sorry, at the end of each period, and also the compounding frequency, the compounding period for your interest rate is equal to payment period. Okay, so we're going to discuss only this one this week. Okay, but you need to remember this. Any question on this? All right, no question. I'm gonna go to next PowerPoint. All right. All right. So now we want to discuss the future value and present value of an ordinary simple annuity. Okay. So as I said, ordinary means that your payments are done at the end of each payment period, and simple annuity means that your compounding frequency for your interest rate. Sorry, the compounding frequency for interest rate is equal to your basically payment period. Okay. So in an ordinary simple annuity, payments are made at the end of each payment period, and the compounding period is equal to the payment period. Okay. So okay. So all right. First of all, let's see what's the annuity means. Okay. So for example, okay, you put your money in the bank for 5 years. Okay, you do basically the payment every year. Okay, and then you want to know what's the future value of this annuity. Okay, so how do you calculate this? Okay, so for the first payment, you put the first payment at the beginning of the first year. Okay, so after 4 years, okay, you will have this future value for the first payment, right? So and you do the second payment after a year, and after 3 years you will have this future value. I mean, future value means at this point of time. Okay, after 4 years, you're gonna have this future value for this guy, this future value for this guy, you're gonna have this future value. So these are all you can consider basically annuity as an investment, as a regular investment, and each payment is gonna basically have interest on it. Each payment is gonna accrue interest over a year based on the simple principle, basically simple based on simple investment. Okay, simple investment for formulation, right? So you have future value for this investment after 4 years is going to be payment multiplied by 1 plus I power of 4, right? Because you have 4 years and your interest rate is yearly, and then it's going to be 1 plus I power of 4. Okay, and for this payment also we'll have 3 years, then it's going to be this guy as a future value, and for this guy it's going to be this guy as well, because it has 2 years, and then you have the PMT 1 plus I power of 2. So you can consider each payment as a single instance of investment, okay, with the present value equal to PMT, right? PMT means the payment, okay? The present value equal to PMT, and the future value is going to be PMT multiplied by 1 plus I power of n, right? So I, which is going to be periodic frequency, basically interest rate, and n is going to be number of compounding period. Okay, so each instance of this payment can be considered as an investment, as a present value, and you can find the future value for them. Okay, so future value for ordinary simple annuity is going to be written like this. Okay, but this is a really long formula, right? You can't really use this if you have like 20, then you have to have 20 of this term, and if you want to use calculator for them, it's going to be very, very long and then very frustrating, right? So mathematicians make your life much easier to find a formula for this. So this summation here is equivalent to this. Okay, is to this. So basically, for an ordinary simple annuity, ordinary means your payment is going to be done at the end of each payment period, and simple means your compounding basically period is equal to payment period. Okay, so it means that if you have compounding, if you have basically a nominal interest rate with compounding, which is compounding monthly, your payment has to be also the monthly. Okay, what does it mean? Okay, the interest rate compounding period has to be equal to your payment period. Okay, so that's basically simple annuity. Ordinary means your payment is done at the end of each payment period. Okay, so for ordinary simple annuity, the future value means okay, so you put $1,000 each month in the bank. Okay, and you want to know after 20 years how much money you have in the bank. Okay, if your interest rate is going to be like 10%. Okay, compounded monthly. Okay, so that's the future value. That's the future value after 10 years. You want to know how much you have. Okay, and that's how you calculate the future value. Okay, it's going to be PMT 1 plus I power of n minus 1 divided by I is going to be basically periodic interest rate for that period, and n is going to be total number of compounding period. Total number of periods. Okay, total number of periods is going to be n. I is going to be basically interest rate, periodic interest rate. Okay, so that's equation for how to calculate future value for ordinary simple annuity. Okay. Yeah, so accumulated value or future value of an annuity, future value is the equivalent value of the series of payment at the end of each term. Okay, so this future value is equivalent to all payment. All payment has been done until now, until today. Okay, so until the last until end of the period. Okay, so that's how we calculate the future value for ordinary simple annuity. Okay, any question, guys?
No.
Yeah.
I have a question.
Yeah.
I want to just ask that it's always that we will have a choice between using the financial calculator or doing the calculation on our own.
Sorry, Pranshi, can you repeat your question? Can you repeat question? Repeat your question.
Yeah, I'm
Yeah.
saying that will there be choice every time that do we want to use the financial calculator or do the want to do the calculations on our own?
Okay, so there is a function in financial calculator as well. For this, we're gonna review that as well in this lecture. It's up to you. So it's up to you how to do you want to use a financial calculator or formulation. But for few first example, I would suggest use the equations so that you get familiar with equations, and then you can use the financial calculator as if you like. Okay.
Okay.
So it's just up to you. So okay.
One last question, Professor.
Yeah.
Sorry to disturb.
Yeah.
I want to ask that as there was first graded test, right?
Yeah.
So is there any another midterm test for the MBF, sorry,
Any what?
midterm test?
Midterm test. So the test 2 is you should look at the basically your content in Blackboard, right? So if you go to Blackboard and then let me review as a student. Let's see. The student preview, okay? So you go to Blackboard, you see basically you go to basically, let me see. You go to announcement. There's not an announcement. This is in basically. Okay, so it's not. Yeah, weekly session. You go if you go to weekly session. Week 5 you test 1, right? So week 9 is your test 2, right? So and you have a study week, which is going to be 2 weeks from now, okay? And then week 9 is your test 2, and your final test is week 14, okay?
Okay.
So, yeah. And then okay, so also here you can see the addendum of the class, right? So week 5, which you already did the test 1, 6th of February. Week 6 is today.
Yeah.
February 13. This is a different course. Today, and then week 7, and then study week you have here, and then week 9 is going to be test 2, right?
Okay,
Test
so
2.
there's no specific midterm, right? Only tests, graded tests.
Only tests. That's right. The tests are your midterms, basically.
Okay,
Tests are your
thank you,
midterms.
Professor.
You're welcome. Tests are your midterms, yeah. Midterms, and then your final test is your test 3. Okay, so these are tests are basically your midterm and your final term. Each are so final test and they're all weighted 25%. The test 1, test 2, and test 3. They're all equally important. So there's no final test and a mid test. So this is all equally important. 3 tests, and they're all equally important. So yeah.
Okay, thank you so much, Professor.
You're welcome. So. All right, so let's go back to the equations. Okay, so as we said, the future value for an ordinary simple annuity is basically payment amount multiplied by 1 plus I power of n minus 1 divided by I. So I is periodic interest rate and n is number of compounding period. Okay. So that's very similar to regular investment. Remember, regular investment was present value 1 plus I power of n. You only have minus 1 divided by I here. Okay, so it's just very similar equation, but you have to make sure this is ordinary simple annuity. Means that your payments are done at the end of each month. Sorry, end of each period. Each period. I don't want to say months because each payment is done because can be weekly, can be bi-weekly, can be monthly, can be daily, can be yearly. So your payment is done at the end of each payment period, and your basically annuity is simple, means that your compounding period for your interest rate is equal to your payment period. Okay, so compounding period. So for example, the compounding period. For example, if I'm paying, as I said, for my car monthly payment, my interest rate is compounded monthly. If my interest rate is compounded monthly, then and I'm paying monthly for my car, then my annuity is going to be simple. Okay. But if my interest rate is compounded yearly, but I'm paying monthly for my car, then it's going to be general annuity. Okay. So general annuity is different than simple annuity. Okay. All right. So which of the following statements best describe an ordinary simple annuity? A. Payment are made at the end of the period, and the compounding period is different from the payment period. So this is not right, right? So the compounding period has to be equal to payment period. This is not right. B. Payment are made at the beginning of the period, and the compounding period is the same as a payment period. Okay. Payment are made at the beginning of the period. Okay, so beginning of the period. This is wrong, right? Ordinary simple, right? Ordinary means you do at the end of the period. Okay. Payment are made at the end of the period, and C. The payment are made at the end of the period, and the compounding period is the same as the payment period. Okay. So this look right, right? So payment are made at the end of the period, and the compounding period is the same as payment period. Okay. This is right. So, and then the last one, payments are made at the beginning of the period, and the compounding period is different. So this is not right. So okay. So this is so let's see what are these. Payments are made at the end of the period, and the compounding period is different than the payment. So this is general, right? The general annuity, because compounding period is different than the payment period. This is general.
Ordinary general.
Exactly, ordinary general. This is ordinary.
Yes.
Ordinary because this is the payment I pay at the end of the period, and general because the compounding period is different than the payment period. Okay, payments are made at the beginning of the period, and the compounding period is the same as the payment period. This is
simple annuity too.
Do simple, right? Do simple annuity, right? Payments are made at the beginning of the period. This is do, and the compounding period is the same as the payment period. Simple. Do simple. This is do because it's done at the beginning of the period, and compounding is equal to payment period. This is do simple annuity. Okay, this is ordinary simple, and this is payment are made at the beginning of the period. This is do, and the compounding period is different than the do general, right? The compounding period is different than the payment period. The do general, right? All right, so Rick invested $360 at the end of every month for 12 years in RRSP, assuming that the interest rate is constant at 7.5% compounded monthly over the 12 years. Calculate, all right, the accumulated value of his investment. Okay. So so first of all, the most important thing you want to check first, at the end of every month. So this is going to be ordinary. This is going to be ordinary, right? So end of every month. Okay. If it's the beginning, it's going to be due. Okay. And this is first check, ordinary, and assuming that the interest rate is 7.5% compounded monthly. Okay. This is compounded monthly, and it pay at every month compounded monthly. So this is going to be simple. This check you have to do all the time for any question, because you're going to have more questions that is going to be different kind of annuity. Okay. First check, end means ordinary, and the compounded monthly, and you're paying every month. So this is going to be simple. So this is going to be ordinary simple. Ordinary because end of every month, simple because compounded monthly and you're paying every month. Okay. So ordinary simple annuity. So you can use the equation for ordinary simple annuity, which is here, right? Equation for ordinary simple annuity. Okay. Okay. So calculate the accumulated value of his investment. Okay. So payments are made at the end of each month. So each payment period, which is monthly, and compounding period monthly, which is equal to payment period monthly. So ordinary simple annuity, as we said, okay? And now how do you calculate the future value? We have an equation for that, right? So equation is, so equation is you need to find n, which is number of compounding period, and we need to find I, which is going to be basically J divided by M, right? J divided by M, right? So this is the same principle as regular investment. You need to find n number of compounding period, and I basically periodic interest rate, right? So the same concept, okay? So you need n is going to be, in this case, it's going to be compounding frequency, which is going to be 12 multiplied by t, total number of time, number of year, total number of year. It's going to be 12 by 12 is 144, and I, which is going to be periodic interest rate, is equal to J, which is this guy, is 7.5%, and nominal interest rate divided by 12, number of basically compounding frequency, right? So this is the example which you solve all the time. So this is going to be this. So you have n, you have I, then you can use this equation, right? So this equation, PMT, which is $360, and 1 plus I power of n minus 1 divided by I, okay? And then if you put this stuff there, let's put this stuff there in the calculator, okay? Let's calculate this in the calculator. 1 plus I power of n minus 1 divided by this guy, okay? Let's do it in calculator and multiply by 360, okay? Let's see how we do it in calculator. First of all, we need to calculate the most interior thing, right? This guy. 1 plus 0.00625, okay? Let me do it in calc, okay? So all right, let's do it in calculator. People are showing up very late, actually. All right, so in calculator, we want to calculate this, okay? We want to calculate the whole thing, but we have to calculate first the most interior thing, right? So 1 plus 0.00625 power of 144. 1.00625, right? 1.00625 power of 144. Power of 144 equal to, okay, and then minus 1 equal to, so this is going to be the denominator, right? Divided by denominator, divided by 0.00625, which is going to be denominator, right? Equal to this guy multiplied by 360, multiplied by 360, equal to this guy, yeah? Yeah, 83,676.8, okay? Yeah, so that's how you calculate this. So basically you go from the most interior one, which is going to be this guy. This 1 plus this is going to be 1.00, right? So this is 1 is just come add with 0 is going to be 1.00625, okay? 1.00625 power of 144 minus 1 divided by this, and then you do the rest, okay? So, and then his total investment over the term. Okay, so how much does he invest over the term? So, okay, so we calculate the future value, right? So future value for his investment, he put $360 in every month for 12 years. Okay, so he basically saved his money. Okay, every month he saved $360 for 12 years, which is really a long time. And this compounded rately, he saved $83,000, right? So it's very interesting. If you save for $360 every month for 12 years, then you have that much money. That's incredible, right? So it shows the power of saving. And then the question is that how much interest is he earned? Okay, so his total investment over the term is 300. So what's his total investment, right? So future value is his investment plus interest, right? So you want to know how much he invests totally, like how how much money he put there, right? He only put 51,840, right? He paid $360 for how many payments? 12 years, every month, like 144, right? 144 payments for $360. If you multiply together, it's going to be 51,840, okay? But with investment, but with the basically with the with the interest, he has $83,000, right? With interest. So what the interest earned? He basically future value of his annuity, okay, minus minus the money he put in the bank is going to be the interest, okay. That's huge interest, right? That's huge interest for that investment, right? He only put $51,000, but he received $83,000, right? So he saved. He basically get a lot of money out of interest, right? $31,000, almost 60% of his investment he got it as interest. Okay, so that's how that's why how we. Yes, yeah. What's the question? Yeah. Yeah, so it's basically that's how we calculate the interest which he earned, right? So the future value of your annuity minus total investment. Total investment is payment multiplied by n number of compounding period, right? So 360 multiplied with the whole n. N is going to be number of compounding period, which is going to be compounding frequency every month multiplied by number of year, right? So it's 12 by 12, 144 multiplied by 360 is going to be 51,840, and then the future value of his investment after 12 years we calculate like this, right? So calculate like this. This is the future value for his investment, right? So that's basically means that the money he earned after interest, right? So this is basically the future value of ordinary simple annuity, right? So that's the future value of ordinary simple annuity, which is this one, because each payment he put in the bank, he gets some interest on it, right? So as we discussed, each payment he put in the bank, he get interest after a year, after 12 years, he get interest, and then all this interest sum up to this number. So this number is going to be future value. And then if you deduct that future value from basically the money he put in the bank, which is $360 multiplied by 144 payments, right? 12 years of every month, then we're gonna have this amount as interest. So, yeah. All right. So, any question?
May I ask why is the what is it if it can we go back to the last slide, please?
This slide?
Oh no, forget it. No, it's far way back, far back, like to the formula, like the bracket. I think it's the next one. The next one when you
this one?
The before this one, like the complicated one. This one.
Yeah.
Why is the n different every time? Like if it's simple and if the interest is like same for every period, right?
Yes. So for every period you get interest, right? So for this payment, okay, if it's 5 years, for this payment, you wait for 5 years, and then after 4 years, you're gonna have this future value for this payment, right? 4 years.
Yes.
Yeah, you're gonna have this future value, right? For this payment, okay. For this payment, you're gonna wait for 3 years, and you're gonna have this future value. For this payment, you're gonna have this future value, and for this payment, you're gonna have this future value, right? So you sum all these future values, you get what you have at this time, at the end, okay? So that's a complicated formula. This is equivalent to this formula. You don't need to sum them. You don't need to do each individual sum. You just use this equation. This equation give you the whole the whole future value for all the summations.
What
This
is
equation.
N?
N is number of compounding period, number of compounding period, number of compounding periods. Yes, and the same as
Why is the fourth period like multiplied by 4 times? Why is N changing? Like,
so N is changing based on your investment, right? So sometimes my call loan is like for 2 years and for every month. So N is going to be 2 multiplied by compounding frequency, which is going to be 12, right? So it's going to be 24 payments, right? So, but for mortgage, you will have 25 years, right? 25 years every month. So 25 years multiplied by 12 is going to be 30. So N is changing based on the number of payments, right? Total number of payments. N is total number of payments, or total number of.
At the fourth period, you pay 4 times. I'm not sure.
No. Okay, so this equation is calculating the future value for all payments from beginning to end. Okay, this equation. Okay, this is the equation which you need to remember. Okay, this future value, okay, is basically the value of the money after you put all the payment to the bank until the end. Okay, until the end. And I is periodic interest rate, N is total number of payments. Okay, N is total number of payment, which is equal to total number of compounding period as well, if your compounding period is equal to payment period, right? So N is total number of payment. Okay, N is total number of payment. I is interest rate, periodic interest rate. Okay, this is the only equation you need to learn to know how much money you accumulated over the time. Okay, just this equation. Just remember this equation. Okay.
Okay.
For ordinary simple annuity. Yeah.
Okay.
All right. Okay, so as you said, we find. So for example, for this example, we find the N, which is going to be total number of payment, or total number of compounding period. The same concept, because the total number of compounding period is equal to total number of payment, right? So total number of payment is going to be compounding, basically 12 payment per year multiplied by 12 years. And we find I, and then we calculate the whole future value based on this equation. Okay, so this equation, please remember that. Okay, so this is the equation which you really need to know when you have ordinary simple annuity. Okay, all right, and then it's just okay. So now we want to use the financial calculator to solve the problem. Okay, so first of all, just make sure that your payment are set to end rather than begin. When you set your payment to the begin, then it's going to be due annuity. Okay, so make sure that you set your payment set to end. Okay, how do you do that? Let's go to financial calculator section, begin. Now it's set as begin. Okay, now it's set as end. Okay, when it's set end means you're basically ordinary annuity. You can change it to begin by second set. If you do second set, you change it to begin. Okay, and if you don't want to begin, you do second set, and you basically set it to end. Okay, it has to set it to end for ordinary annuity. Okay, and then second quit. Okay, so you now basically at the end. Okay, so but if you want to do you want to do annuity, you do second set. Okay, let me quit this. Second begin. So this is basically you're in the annuity mode. So now it's begin. Okay, but if you want to change it to end, second set, and then it become end. Okay, so now you set to end annuity, which means ordinary annuity. So this is ordinary annuity. This is due annuity. Ordinary annuity, due annuity. Ordinary annuity, due annuity. Okay, so since we are working with ordinary annuity, we need to put the ordinary annuity and then quit. Okay, how to set it? As it says, second begin. Now in the annuity mode, and then we can set this. We can play with this. Okay, we can play with this, and then quit. Okay, so now we are in end. Okay, if you want to check it, we are at end, and then out. Now we go to basically calculation. Okay, so we have basically we have to set n. N is how many n? N is basically every month for 12 years, right? So n is gonna be 144. 144 is gonna be n, right? And then 7.5 is gonna be compounded monthly. 7.5 I over y, and then what's gonna be p over y? P over y is gonna be compounding frequency, right? So compounding frequency for this guy is, because it's monthly, is going to be 12. So second p over y is 12. Set, yeah. And then, so the present value has to be 0. 0 is present value because you don't have anything. I'm sorry. So we have to quit that mode. So second p over y 12. Second quit. 0 is present value. We don't have anything in the present value. And then now PMT. Okay, payments are, because you put payments every month in the bank, has to be negative. So put 360 negative as a payment, and now CPT future value is going to give you that. Okay, 83,676. Okay, so yeah, so financial calculator also has this. So the PMT is basically is annuity, right? So in financial calculator, so now you can set the PMT, and you can find the future value. Make sure to put the present value at 0, because sometimes you have some present value, so it's going to be added to the future value. Okay. So it's very simple in financial calculator. Financial calculator, you set the total number of payments, which is going to be total number of compounding periods as well. The same concept. Total number of payment, interest rate, nominal interest rate, and then you have compounding frequency, P over Y, payment over a year, right? Payment over a year. How many payment over a year you have? 12. Okay, and then quit, and then present value has to be 0, and then PMT, and then you put your PMT at 360, negative PMT, yeah. And then your CPT future value. Okay, this is how you calculate it in financial calculator. All right, so $2,000 was deposited at the end of every 3 months for 6 years into a fund earning 7.6% compounded quarterly. Okay, after this period, the accumulated money was left in the account for another 9 years. During this second period, the fund was earning 10.2% compounded quarterly. Okay. I calculate the accumulated amount at the end of 15-year period. Okay. So now we have 2 questions here, right? So we have, so $2,000 was deposited at the end of every 3 months for 6 years into a fund earning 7.6% compound quarterly. Okay. Okay. So first we have this for 6 years, and then this money is still in the bank. Then after this period, the accumulated money was left in the account for another 9 years. During the second period, the fund was earning 10.2% compounded quarterly. Okay, so basically you have an annuity. Okay, an annuity for 6 years. Okay, 6 years, and after that, the money left in the bank without any annuity, but it has interest on it. Okay. So it has interest on it, and so you have annuity first, and then you have regular investment second. Okay, annuity first for 6 years, and then after 6 years is finished, then you have a regular investment. You put your money as a present value in the bank for 9 years, and with this component quarterly, the component basically quarterly, right? So, okay, so first of all, let's first solve the first problem, okay? First problem is you have every 3 months for 6 years in the fund, 7.6 will come out quarterly, okay? So so first of all, every 3 months, okay? End of every 3 months means you have ordinary annuity, right? And compounding frequency here, like compounded quarterly, right? So compounded every 3 months. Your interest rate is compounded quarterly, which is compounded every 3 months, and you put your money every 3 months in the bank, right? So the compounding basically period is equal to your payment period, right? So this is simple, right? So compounding period equal to your payment period. So it's simple. So it's simple ordinary annuity, right? Ordinary because it's end of every period, and then simple because your compounding basically period is equal to your payment period. Okay, compounding quarterly means compounding every 3 months, and you put the money every 3 months, right? So that's simple annuity. Okay, sometimes they tell you 7.6 by compounding daily. Okay, and you put every 3 months. You say, oh my God, these are very different. Okay, we will find it. We'll solve those questions as well. So just right now, just concentrate on the fact that your interest rate compounding period is equal to your payment period. Okay, so now ordinary simple annuity, and then now we have to use ordinary simple annuity equations. So we need to find n, which is total number of payments, and we also need to find I, which is periodic interest rate, right? So n, total number of payments, is equal to compounding frequency, which is going to be 4 multiplied by 6, right? 6 years, right? Compounding frequency is 4, right? So because it's quarterly, right? So okay, so let me explain this equation again. So basically, you have the annuity saved until 6 years, and after 6 years, you stop paying annuity, but you leave the money in the bank. Okay, leave the money in the bank at this point in time for 9 years. Okay, so just get interest on this. On 9 years, you get interest, but the first 6 years you have annuity. You have to calculate the future value. You have to calculate the future value of the annuity at this point of time, at the end of time, and then at the end of 6 years, and then you leave it in the bank as a regular investment, for 9 years, right? So regular investment, we know how to calculate, right? Present value multiplied 1 plus I power of n, right? So that's going to be regular investment. The future value for that. So you first calculate the future value for this annuity, yeah, future value 1, and then this is going to be present value. It's going to be present value for second 9 years. So you will calculate future value 2, right? So future value 1 is going to be the future value for this annuity after 6 years, and this is going to be the same amount is going to be present value for your second 9 years. Okay, yeah. All right. So as I said, how to calculate it? As I said, we need to find I and we need to find n. And n1 basically, n1 for first 6 years is going to be 6 multiplied by compounding frequency. It's going to be 4. It's going to be 24 quarterly payment, right? 24 and it's going to equal 24. I1, which is going to be J divided by M, right? So J is 7.6%. divided by M, compounding frequency 4, it's going to be 0.09, and then okay, so this is the thing which you need for basically calculating annuity. Okay, and for the second period, we don't need to calculate annuity. It's just a regular investment, but we need to find the n and basically I for second part of the investment as well. N is going to be basically, we call it N2. N2 is going to be basically it's compounded quarterly, right? And 2 is going to be 4 again, multiplied by which is going to be compounded frequency multiplied by 9, the total number of years, which is going to be 36, and I2 for the second part for 9 years, right? It's going to be J 10.2 divided by compounding frequency is going to be 4 So we calculate N1 and I1 for annuity, and N2 and I2 for regular investment. Okay. And now we use the equation for annuity. So future value 1 is going to be 2,000 multiplied by this amount, which we already calculated. So this 1 plus 0, this is going to be 1.019, right? So power of 24 minus 1 divided by 0.019. You can do it in calculator, easy. And this number is going to be 60,106.87. Okay. So this is going to be future value for annuity. So this FV1, this FV1 is going to be here, right? So it's going to be here, FV1. Okay. So we calculate the whole amount of annuity after 6 years. Okay. So this is going to be future value of the annuity. Okay. And now this future value annuity is going to be present value for this for the next 9 years. Next 9 years, we don't have any annuity. You just put the money in the bank for 9 years with this compounding quarterly, with this 10.2% compounding quarterly. Just put the in the bank for 10.2% compounding quarterly for 9 years. Okay, so that's just a regular investment. You didn't touch the annuity after this. You just save. The money is left there, and then it become like this. Okay, so it's going to be present value for the second period. Okay. So now, yeah.
So is it the insurance? Do you mean the first period is like insurance? That's why he pay a lot of money, like every like.
Yeah. So okay. So no, you can consider it as an investment. Okay. So you basically, for example, you have some money. You can, yeah. So you basically work for a company, right? So and every month, every 3 months, okay, I saved this money, and this is extra money. I just want to save it. Okay. You talk to the bank. You say, okay, bank, can you give me a good interest rate? And the bank tell you, yes, it's no problem. We can give you 7.6% compound quarterly. Okay. You can pay 7.6% interest rate. Okay. So it's good. So I'm gonna put my money in there. Okay. And then you talk to the bank accepted to give you 7.6%. And then you put the money there. Every 3 months, you put $2,000 there. You save $2,000 every 3 months. You put there for 6 years. Okay. After 6 years, then you lose your job. Okay. You lose your job, and then you can't pay $2,000 anymore. Okay. But you just keep your money there. Okay. So okay, it's no problem. I can keep your money there. I don't want to touch it. I just want to keep my money there. But you go to the bank again and say, bank, can you give me better interest rate than before? Because
so the plan changed.
The plan changed. Yes, plan changed. You go to bank, can you give me a better interest rate, because I have a lot of money now in my account. Can you give me better interest rate? And the bank said, yes, we can give you better interest rate. It can be, pay you 10.2%. Okay, that's fine. I'm just gonna leave my money there. Okay. And you leave your money there for another 9 years, okay? And then at the end of 9 years, okay, I'm going to take my money out, okay?
Okay.
So that's how it works, okay? So the first plan, you pay every 3 months for $2,000 for 6 years, okay? And second plan, you don't touch it anymore. You just get interest over 9 years for that money, okay? That's how it works, okay? And for the first part, the first part is annuity, right? So first part annuity, because you do a regular over a period of time payments, right? Over every 3 months you pay a payment. Okay, so every 3 months you do payment until 6 years. Okay, so that's going to be annuity, and we learn how to calculate the future value for annuity. So we know how to calculate the future value for this annuity. Which we discussed before, and it's going to be this equation: the payment, $2,000, 1 plus I power of n minus 1 divided by I. And what's n is n1 and I1, right? N1 is the total number of payments, which is going to be every 3 months. It's going to be 4 multiplied by 6, 24, right? So every 3 months, 4 payment per year multiplied by 6, right? 24. And I1 is going to be J1, which is going to be this guy, 7.6 divided by compounding frequency, which is 4. So you have N1 and I1. You can calculate the future value for this annuity. Okay. So it's going to be PMT 1 plus I power n minus 1 divided by I. It's going to be this way. So it's going to be $60,000. Okay. So $60,000 after 6 years. Okay. So this is going to be the money which you left in the bank at the end of 6 years. Okay. And now you lose your job. You lose your job. You can't, but you don't want to touch the money. Okay. And then you keep this money in the bank for another 9 years for 10.2% compounded quarterly. Okay. So this is going to be future. This is going to be basically present value. Okay. So future value 1 is going to be present value 2. Okay. For the second period, you have this money as a present value, and then you use the regular investment equation 1 plus I power of n. So I in this case is going to be I2, n is going to be n2, right? I2, which is related to 10.2% compounded quarterly. You have to divide 10.2% divided by 4 to get I2, and n2, which is second period, is 9 multiplied by compounding frequency. Compounding frequency is 4, 9, 4 is 36, right? 36, and I is going to be this guy divided by 4, right? So this. So it's going to be 60,000 multiplied by this. Okay. So at the end of 9 years, you're going to have this money. Okay. Yeah.
Yeah. Yes.
So that's total accumulated value. Yeah. You understand it? Did you guys understand it? Any question on this? Good.
Yeah.
Yeah. Yeah. No. Yes. No. Yes.
Yes.
All right. Okay. All right. Any other
Thank you,
question, guys?
Professor.
All right. You're welcome. All right. Any other question? All right. So okay. So calculate the amount. Okay. So the amount of accumulated value after 15 years, we calculated already. Okay. So now we wanna do it in financial calculator, right? So okay. Let's do it in financial calculator. First of all, let's do it in financial calculator. So in the financial calculator, we need to find first the future value for this annuity, right? This is ordinary because end of 3 months, and simple because compounded quarterly, which is compounded every 3 months, and this is every 3 months, right? So ordinary is simple. We want to do it in financial calculator. Okay, so let's do it in financial calculator. So second, clear TVM. I'm just clearing everything. Second, clear TVM. Make sure you do it before every calculation. Okay. And now you have every 3 months for 6 years. So it's going to be compounding frequency is going to be 4 multiplied by 6, 24. N is going to be 24. 24 is going to be N, right? And then 7.6% compounded quarterly. 7.6%. 7.6 is going to be I over Y. Compounded quarterly means your compounding frequency is going to be 4. So second P over Y 4. Yeah. Quit. And then present value is 0. 0 is present value. And payment are $2,000 every 3 months. $2,000. So $2,000 negative is payment. And CPT future value 60,106. So 60,106 is calculated easy. This is your future value, right? So this is a future value, okay? For this investment, for basically annuity, okay? The first part, okay? And now this future value is going to be present value, okay? It's going to be present value for the next one. Okay, so I just from future value, I push a present value. The present value for next one is going to be this guy. Okay, and then we need to put the negative sign in there as well because you put the money in, and now we need to reset the whole thing again. So now we have different n. The new n, so that we have the present value right now for the second period. Okay, second period is present value. So for the second period, we have 9 years and compounded quarterly again. So 9 multiplied by 4, 36. 36 is going to be this. And then I over Y is 10.2. 10.2 is I over Y. Okay. And then it's again compounded quarterly, which P over Y is going to be 4. So it's going to be 4 again. Set and quit. So we have N I over Y, P over Y, and present value. And we want to put PMT as 0. PMT is 0 because with the second period, we don't have any payment. And now we do this, we find the future value, 148.801, okay? Yeah. So that's how you do it in financial calculator as well, okay? All right, so you need a little bit of work. So it's just a combination of two of those things, yeah, right? So you basically, for the first part, you use the annuity formulation. You use annuity functions basically to find the future value, and then that future value is going to be present value. This future value, which you find here, is going to be present value with the negative sign, right, for the second period. And second period is a regular investment, which you already know how to do it in financial calculator. You find N, you find I over Y, P over Y, and then you make sure the PMT is 0, because the PMT you might left from past part. So put PMT 0, and then CPT on future value is going to give you this number. Okay. So calculate the total interest earned through the 15 years period. Okay. So total interest earned through 15 years period is going to be the last number, 148.801, minus the total number of payment you ever done. Okay, you paid $2,000 every 3 months for 6 years. That's it, right? And then you didn't pay anything for the next 9 years. So $2,000 every 3 months for 6 years is going to be basically how many payments you're going to have. You're going to have 4 payments per year for 6 years. So 24 payment of $2,000, right? So it's going to be $48,000. So $2,000 multiplied by 24 payments is going to be $48,000. So interest earned is going to be $100,000. Okay, so a lot of interest you earn if the interest rate is high. Okay, it's 7%, 10%. You earn a lot of interest. You paid only $48,000, but you get $148,000. Okay, so that's how you calculate the interest earned. Okay, so you only paid for first 6 years for $2,000 every 3 months, and then the next 9 years you didn't pay anything in the account. It's just interest, and that's it. Okay. All right, so we're gonna call it quit now. If you don't have a question, we can basically call it off and then come back in 15 minutes. Do you have any question, guys?
Yeah, Professor. For the test, I want to be able to review the test.
I don't think that you can review the test. No, the test questions are not. I don't think you can look at the test question. You can only go through the test and then do them and finish but I don't think you can review them. I can ask this question from course lead, so I'm not sure whether you can review.
Because I think the mark that I got is not as much as I think it would be. And I'm not sure if it's my computer, but seriously, because I've done the question for lots of time before, similar question before, and there's no way this time I use the calculator you show us, like, and then I double check with different method, it's still the same. So I don't know what is wrong. I don't know what is wrong, because I use both calculator and the algebra method to make sure that they are the same. I think it's maybe because the question didn't show. Maybe the question didn't show because I tried mock test before the test, and when I do the mock test, the question didn't show, and then it just count me 0 for that question. But like that's one question they're supposed to have three questions,
Okay.
like three
So if
little
if you
questions.
guys if you guys have any question regarding test and how the test is operated, you need to contact Reta. If you have difficulty to doing the test, if the test doesn't show up, if you have any technical difficulty to do the test, you need to basically contact Reta. Say you have this difficulty to accessing the test. Okay. So any technical issues about test, you need to contact Reta. And if your reason is justifiable and the Veritas say yes, that's true, that's a justifiable reason, then we give you extension on the test. Okay, you can retry the test. Okay, already we have a couple of people retry the test because they couldn't make it for some reasonable reasons, right? So reasonable reasons, but yeah, so the test is done and the mark is there. So make sure for the next test, just make sure that you prepare, and if you have any
I'm actually
technical,
prepared, so it's not my fault.
yeah, just make sure that if you have any technical difficulty doing tests, contact Beretta and also CC
I
me.
didn't know it's a difficulty because I thought the question supposed to be supposed to be 3 questions, but I only have to do 1, and I only one showed up, and I finished those questions, and I'm pretty sure they're not that difficult, and I've done similar question for many times. I use both methods for that test to make sure they match, and then well, I only got 68%. Maybe it's because the question didn't show up, and I didn't have a chance to complete it. It didn't show up. I can't, nothing to do. Okay, I can't do anything.
Contact Beretta and CC me. Okay, if you have any question, contact Beretta and CC me. If you have any technical difficulty, also Beretta is going to answer me and you with basically statistics. So give you the time you spent on the question, which question was that.
It's not only reviewable. It's not even like, I mean, it's not, if it's reviewable, I know what the problem is, but I don't know what the problem is now.
I don't know. You probably answered wrong, right? So it's just if you answered wrong, then you don't get the mark for that. Okay. But anyway, so if you have any technical difficulty with the questions, just send an email to Reto and also CC me so that I would be in the loop so I can follow up with them. Okay. Thank you. Any other question, guys? All right, we're gonna reconvene in 15 minutes, like let's say 1:20. We can reconvene at 1:20. Okay. See you guys in 1:20. Okay. All right, so all right, guys, we're gonna start. If you don't have any question, we're gonna start the next part of the lecture. All right, no question. I'm just gonna share the screen for the next part of the lecture. All right, so we learn how to calculate the future value of ordinary simple annuity, right? So I just want to reiterate what the annuity means. Annuity means the payment you pay every at the certain period of time, and how to calculate the future value. What does future value means in an annuity? The future value means when you put the money in the bank and bank give you interest rate. So for each payment you will receive an interest, right? So at the end of your payments, like after 2 years or 3 years or 4 years, you will have a value in the bank, right? So you will have a value of the money in the bank, and that's going to be your final value or future value of your annuity. Okay, so that's going to be investment. Okay, that's generally an investment. So you invest money in the bank pay you interest rate, compounded quarterly or monthly or whatever. So depend on your type of payment, the bank also give you the interest rate. Okay. But sometimes you want to calculate the present value of annuity. What does present value of annuity means? Okay, so the present value of the annuity means the other way, right? So for future value, you want to calculate the investment. So you put the money as an investment in the bank and you get interest on it. Okay, but for present value, you borrow a money from bank. For example, for your car, for your mortgage, you borrow a money from bank, which is called present value. Okay, and you need to pay payments toward basically amortizing this payment, this present value, to annihilate, to basically diminish the present value over a period of time. Okay, so over a period of time, with the equal payments, you get rid of this present value loan. Okay, for example. So, for example, for first months, the present value for first let's say this is our monthly. Okay, after first month, the present value is going to accrue interest on it, right? So we're going to have here a present value plus an interest, and you do the first payment out of it, right? So the first payment is going to be deducted from present value plus interest, and then you're going to carry forward for next month, and again is going to be deducted, and again it's going to be deducted. For example, if you have $1,000 at this time as a present value, after a month, and you have interest rate like 5% monthly, after a month you will have 1,050, okay, as basically present value plus interest that you have to pay, and you pay every $100 every month. Okay, so you deduct $100 from it. Let me just pay. Let me just say this is not. Let me just use a paintbrush. Actually, I think it's easier. Paintbrush. Yeah. Do you see it? Do you guys can see it? Can someone tell that can see it? Hello? Yeah?
Yes.
Yes.
All right, sounds good. All right. So for example, okay, so you borrow $1,000 here, okay? 1,000. My drawing is not that good too, right? So $1,000 here, okay? And you get like 5% monthly per month interest, okay? Which is going to be like 60% compounded monthly, right? 60% annual, but just an example, right? So 5% monthly, okay? So after a month, you will have if you borrow this money from bank, $1,000, okay? After a month, you have to pay with interest. You have to pay 1,050, okay, right? Because 5% of 1,000 is going to be $50, and then after a month, okay, this is a month, 1 month. Sorry guys, I'm slow in writing, okay? I'm just 1 month, okay? So $1,050, okay? And now let's assume that your annuity is $100 per month, okay? So you pay $100 here from this guy, okay? From this guy. From $100 deduction from this guy is going to be $950. So what left in this month is going to be $950, okay? And then this carry forward for them to next month, right? So 5% of 950 is going to be, I don't know how much it's going to be. Let's 10% is going to be 95, 47. So it's going to be 47 and a half. You have to, so it's going to be 1,000. Sorry, it's not going to be 1,000. It's going to be 997 and a half. Okay, that's going to be this month, beginning of this month with interest, and then you pay another 100 from this guy. It's going to be 897 and a half. Okay, 897 and a half. That's going to be so. That's going to be the, after payment. So this 997 and a half is going to be after interest, and after you pay the $100 from this, it's going to be 897 and a half at the beginning of this month, and then you carry forward to next month, which is going to be another 5% of this added to it, and then you deduct $100 from it, and it's go so on and so forth until you do the last 100 payment, and this loan cleared. So at the end, you're left with $100, and then you pay the $100 at the end, and the loan is going to be cleared. 100 minus 100 is going to be 0. Okay. So that's basically the present value of this annuity. Okay. So this annuity, basically this annuity, which you paid every month, okay, for a certain period of time, has a present value, and that present value, which is going to be that money, that, for example, for this case, $1,000, is going to be basically the original loan, the original borrowing money, the original thing that you borrowed that you want to pay it back with this annuity, which is over a certain period of time, over a certain period of time, over basically payment periods, right? So over a certain period of time, like 10 years, you pay every month $100 to basically clear the loan which you get it at the first place. The loan which you get at the first place is a present value of the annuity. Okay, so that's the concept of present value of the annuity. You see? So present value annuity of this annuity is the original money which you basically borrowed, and you want to pay it back with this scheme of payments, right? So a payment period over a period of time. Okay, that's the meaning of the present value of annuity. You understand it? All right. So again, we have ordinary simple annuity. We only discussed the ordinary simple annuity in this lecture. But from next week, we're gonna discuss about the do simple, ordinary general, and do general annuity. So next week we're gonna cover all the other three, because this lecture I'm just gonna make it very simple for you guys, so that you don't worry about the why if the interest rate is not compounding the same as your payment period, what's going to happen. So it's going to make you a little bit confused. So I just want to make it very simple. You do ordinary simple, means that your compounding period for your interest rate is going to be the same as your periodic payment. So, and ordinary means that you pay the payment at the end of each payment period. Okay, ordinary simple. So the equation for ordinary simple annuity present value is going to be PMT 1 minus 1 plus I minus N divided by I. So that's how you calculate the present value for this annuity, which is compounded basically. Can be monthly, can be daily, can be whatever, compounded over a period of time, and with the N is total number of payment period. So N is total number of payment period, which is the same as total number of compounding period, and I is an interest rate, periodic interest rate. So I is a periodic interest rate. So it's not nominal interest rate, it's periodic interest rate. Similar to ordinary investment, you can calculate I and you can calculate N. So I is going to be J divided by M, which is M is going to be the compounding frequency, and N is going to be M compounding frequency multiplied by number of years. Okay, the same way of calculation that applies for previously is going to apply here. So that's the equation. Please memorize it. Okay, so it's just present value for basically an ordinary simple annuity. Ordinary simple annuity. Okay. All right. So let's solve some question. Nick purchased an annuity that provided him with payment of 1,650 every month for 18 years at 8.16% compounded monthly. How much did he pay for the annuity? Okay. So that's basically. That's basically a question of present value, right? So he purchased it, and now he has to pay every month 1,650 for 18 years at 8.16% compounded monthly. So that could be a house, right? 18 years you pay 18 years for this interest rate. That could be a house. So you pay 1,650. So how much is the annuity? Okay, so this is as I said is a present value. Why? Because he purchased something and has to pay it off. Over a period of time, and this amount. And now let's see. Is it ordinary simple, ordinary general, do general, or do simple? So every month. So probably payment you had to pay every month. So it's going to be at the end of every month. So it's going to be ordinary, and it has to be at the end. So this is the PowerPoint has a problem at the end of every month, ordinary, and for 18 years, and 8.16% compounded monthly. So this is compounded monthly. So periodic payment, which is every month, is going to be compounded period. Compounded period is monthly, which is equal to periodic payment. So since these two guys are the same, so it's going to be simple. So it's a simple and an ordinary annuity. So we can use the simple ordinary equation. Okay. So what was the equation again? PMT 1 minus 1 plus I minus N divided by I. Okay. All right, so let's go back again to this. So payment at the end of each period, monthly, compounding period, which is monthly, compounded monthly, is equal to payment period, which is monthly, right? So it's going to be ordinary simple annuity. So he paid every month, and then you want to know what's the present value, or what's the amount we purchased at the beginning. Okay, and how do we do it? So basically, we have N. What's N? N is going to be compounding frequency multiplied by by number of year. Compounding frequency in this case is 12 because it's every month, and multiply by number of years, which is 18. So the other way you can do that is you can say, okay, how many payments this is? N is the total number of payments, right? Total number of payments is going to be how many payments it does per year multiplied by number of years. So how many does per year is going to be 12 payment per year, right? So 12 because he paid every month. So it means 12 payment per year multiplied by number of years, which is going to be 18. Okay. The other way you can do it, you can also multiply the compounding. You can say this is compounding frequency. This compounding frequency is 12 multiplied by 18. Okay. That's two way of thinking about this. Okay. I leave it to you guys, which one is more comfortable. If you want to keep the old stuff which you learned, which is basically how you calculate n. N is going to be m by t. M is going to be compounding frequency. You can go that route, or you can say, okay, m is going to be number of payment per year and multiply by year. This just doesn't really matter. They both are the same. Okay. And then it's going to be 216 payment, and then you need to find I, which is going to be this guy, 8.16 divided by 12, right? So it's 8.16 is J divided by I divided by 12. This compounding frequency is going to give you I. So this is going to be this. Okay, let's do this in calculator because this is more complicated than the other one. Okay, so I in this case, well, I don't know why this PowerPoint didn't calculate I for you guys. But anyway, I is 8.16% divided by 12. So that's going to be I. Okay, so let's do this in calculator. Okay, let's go this guy in calculator. All right, let me clear everything. And now I want to do this in calculator. Okay, so first of all, I need to do the most inside one, this one first. Okay, so 1 plus 0.0068 is going to be 1.0068. Okay, 1.0068 power of minus 216, power of 216 minus, okay, equal to this amount. Okay, and 1 minus this number. Okay, so we need to store this number at 1. Okay, 1 minus this number, 1 minus, recall 1, equal to, this is going to be numerator. Okay, store it in 1. Okay, this denominator is stored now. Denominator is this guy. Okay, 0.0068 divided by 0.0068 equal to this guy, 113, and now you have this whole thing. Then multiply 1650, multiply by 1650 equal to $186,000. Okay? Yeah, 186,510. Okay. Yeah, did you got it? Did you got how to calculate this with the calculator? Just inside, you do the inside guy, power of this, and then you store it because you want to do 1 minus this guy. 1 minus recall 1, and then you have denominator and divided by denominator and then multiply by this guy. Okay. That's how you calculate in calculator.
Hi, Professor.
Yeah.
I have a question about purchasing an annuity, and what does it mean when you say provide him with payment of 1650? Does it mean that he gets that much money?
This one 1650.
Yeah, he received this money.
No, he doesn't receive this money. He paid. Right? He purchased an annuity. Okay, he purchased a car. He purchased a house. Okay,
because it says provide him. Like it confused me a bit. But he's supposed to be the one that pay.
He's supposed to be the one that pay for the thing which he borrowed at the beginning. Okay, and he borrowed an annuity. He purchased an annuity. Okay. And then has to pay for it, right? Has to pay every month, 1650 every month for this interest rate monthly for 18 years. Okay. So now the question is that how much was that annuity that he bought? How much is the annuity that he bought? Okay. The annuity he bought, as I said, is as I said here, the annuity you want to know what's it's going to be present value. The present value of this annuity is going to be the amount he bought. The amount
Yes.
he bought, it's going to be the present value. And then how do you calculate it? With this equation, okay? With this equation, you calculate it. PMT, which is a payment, multiplied by 1 minus 1 plus I, minus n divided by I is going to be periodic interest rate, and n is going to be number of compounding period, or number of total payments. They are the same. Number of compounding period and number of total payment is the same. So total number of payments, okay? Going to be the same. So use this equation, present value, okay? You have to use this equation because you want to know how much he borrowed that he has to pay now all these years for that. How much he borrowed. That's the present value, okay? And then you use the present value equation. So that's how much he borrowed. He borrowed $186,000, 510 for a house probably, and then he has to pay this amount for 18 years at this rate to be able to clear it out. So after he paid all these months for 18 years, he's going to clear this loan out. Okay? You understand?
Okay.
All right. All right. So how do you
Thanks.
calculate this? How do you yeah? Do you have any question? Anyone else has a question? No? Yes? No? Yes? All right. Okay. So so let's do this in financial calculator because the life is much easier in financial calculator for sure. So so we have in this case we want to know what's the present value, right? So we want to know what's the present value. So so in this case, we want to know what's the present value. So let's go to financial calculator. Let's clear everything first. Clear. And now we know the payment is 1650. At least we know the payment 1650 is going to be payment, right? And now we know the 8.16% component monthly. 8.16% is going to be I over Y, component monthly, which is P over Y is going to be 12. Set, right? Quit. And now we need to know N, right? N is going to be 12 multiplied by 18. It's 216, right? 12 multiplied by 18 is going to be 216. N is going to be this. So we set N, we set I over Y, we set PMT, we set the component frequency. We don't have any future value. We need to know what's the present value. So CPT, present value. That's this 186,510. Why is negative? Because he borrowed this. So you can put payment at negative, and this guy is going to be positive. Okay. So the sign for payment and present value is going to be different. So 186,510 for 0.944. Okay. So that's he borrowed. Okay, it's very easy to do it with financial calculator. It's very similar to regular investment. So you put I there, you put N there, you put I over Y there, you put component frequency there. You find the present value or you find the future value. Okay, you can also, I think you can also find the future value for this. If I put the present value as 0, I can find the future value for this scheme, which is going to be $806,000. Okay, wow, that's a big one. Yeah. So anyway, so so that means that if he saved the money in the bank, it's going to be that much money. Wow, that's interesting. Wow, if you put the money in the bank regularly, 1650 every month, they're going to have this after 18 years, $806,000. Wow, that's a lot of money. Anyway, that's interesting. But if he just pay for that mortgage, that's interesting. If you just pay for that mortgage, he's clearing a $186,000 mortgage. Okay, but if you just save the money, he's gonna have at the end of 18 years, he's gonna have $806,000. Wow, that's incredible. Something to think about. All right. Okay. Wow. You understand that? You understand the concept of interest? You see after 18 years, if you just if you just save this money after 18 years every month for this company with this interest rate, after 18 years, it's going to have $806,000, right? But if you just buy the house, after 18 years with this scheme, he's only clearing $186,000 loan. But you can just save, you can just save this money 4 times as much. You see how the banks are ripping us off with this mortgage? Interesting. Anyway, so yeah.
Actually, I'm getting different present value on my calculator by using these values.
Let's do it together, okay? Let me just clear. You have to do clear TBM, right? Second clear TBM, second clear work. Okay, let's do it. Let's do it with me, okay? So what is n? 216, right? 216 is going to be n. Yeah. What's I over y? 8.16. 8.16 is I over y. What is payment? 1650. 1650 is going to be payment. Make sure future value is 0. 0 is future value. Just make sure. And then go to P over Y. That has to be 12, right? Monthly. Right? Set. Yeah. And quit. Now everything is set. You need to do CPT, present value, 186,510. Yeah. Yeah.
I think I didn't put 0 in future value. That's why I got the wrong answer.
Oh yeah, yes. You have to put 0 in future because if you have something in future, it's going to come to present as well, right? So you might have something, okay? You have annuity, but at the future you might have something you want to move it to present, right? So that could be a problem. So that would be added, basically it would be added as a regular investment to your present value. So you have to make sure that you have the future value 0, because in future you want to clear this loan, right? You want to clear the whole loan, right? So
yeah.
So basically at the future you're gonna have 0. But what's fascinating me about this, guys, is just if you put present value as 0, right? And consider this as an investment, and then you put CPT on future value, you have $806,000, right? So you have like 4 times as the money as you borrowed, right? You borrowed $186,000, but after 18 years, if you just put it as investment, you have 4 times as the money as you borrowed. So basically, you can basically save 4 times, right? If the interest rate is high, right? If the interest rate is high, you just don't need to buy anything. You just put the money in bank and get interest, right?
It's really rare to have a good interest like that, right?
Yes.
Yeah, the interest is pretty high. Yeah.
As you said, it's a high interest.
Yeah, but right now bank is giving you like 4% interest, right? It's not too bad though, right? 4% interest. So bank is only in GIC account, you can get like 4% interest. 4% is not too bad. So I don't know. It's just something is just blowing my mind, right? If this interest rate, you get like 4 times as the money you borrow. Anyway, so that was pretty interesting. So anyway, so total amount received. So okay, so you wanna know how much interest you paid, right? So in this case, you want to know how much interest you paid. So you bought the house with this amount, and then you pay this amount monthly. Okay, so how much you paid totally? How much you paid is 1650 multiplied by total number of payments. It's going to be 12 by 18, right? So it's going to be $356,000 you paid already. And how much was the present value? Present value was 186,000. So against that, you paid $169,000 only interest. You paid only interest $169,000. Okay. So out of your payments, this was basically your interest. If you basically, even now with like 5% mortgage rate, if you just go and buy a house, that's ridiculous amount of interest you have to pay after 25 years, right? It's going to be almost double the amount of the house you have to pay as interest for 25 years. Right now it's like 5% or 5.5% interest rate. for the mortgage for the house is basically you almost need to pay double actually with the today rate. So after 25 years. So yeah, but what's really tempting me is just put that money in the bank for every month, and then at the end you're gonna get a lot of money. That's pretty interesting actually. So you pay $169,000 interest on this. Okay. All right, babe. So let's do another example. Peter paid $24,000 as a down payment toward a house purchase and received a mortgage from a bank for the rest. Okay. He paid $1,380 at the end of every month for 30 years at the interest rate of 3.6%. This is more regular, compound monthly to settle the mortgage. Okay. So now, this is a very, very realistic example, right? So right now, mortgage rate is even more. Mortgage rate is like 5%, 5.5%. So you pay $24,000 a down payment and then pay $1,380 every month for 30 years at interest rate 3.6% compound monthly. Okay. End of every month and compounded monthly. End of every month means ordinary. Compounded monthly means and he pay every month. Compound monthly, and there is a month, and every month means it's simple, right? Ordinary simple annuity here, okay? And so he paid $24,000 at the beginning, okay? So we need to keep in mind that he paid $24,000 in the beginning, but he paid the rest with this annuity, okay? So the present value for this annuity is going to be the amount that he borrowed, but we have to keep in mind that he paid $24,000 at the beginning as well. So the present value of annuity has to be added to $24,000 to see what was the original amount of the house, right? So because he paid $24,000 and the rest is going to be this annuity. So we find the annuity present value. So it's going to be whatever it is has to add it to $24,000 to give you the basically the mortgage amount, right? The original house amount. Okay. What was the purchase price of the house? So let's first of all go through that. This is ordinary because you paid at the end of every month, and it's simple because it's compounded monthly and he's paying every month, right? So interest rate is compounded monthly and he's paying every month. So the ordinary is simple. So then you need to know what's the present value, and after we find the present value, we add the down payment to it. It's going to be a purchase price, right? So purchase price, you pay down payment, and the rest of it you pay with the scheme, right? With the annuity. Okay. And now, so how do we do it? So we first need to find N, which is going to be total number of payment or total number of compounding period. Total number of payment is going to be 12, which is number of payment per year, multiplied by 30. 12 can be also compounding frequency as well, right? So it's just the same concept. Multiplied by 30, 360. And now I is going to be J divided by M. J is 3.6 divided by 12. It's going to be 3.30 months. And now we have to use this equation, right? PMT 1 minus 1 plus I power by minus N divided by I, okay? So let's do this again in calculator together. 1.003. So this, you want to even calculate the whole thing, right? 1.003, right? Power of minus 360, okay? 1.003 power of 360 with a negative sign in front of it equal to this guy, okay? 0.34. Now we want to do 1 minus this guy, okay? So we need to store this guy. Store to 1, and now 1 minus recall 1, okay? Equal to this, 0.65. And now divided by, so this is going to be a denominator divided by 0.003 divided by 0.003 equal to this, 290, and then multiply by 1380. Multiply by 1380 equal to 303. Okay, 303.533 is going to be present value for the mortgage, right? And then you have to for the annuity, and you have to add 24 to it, right? So 24, 327.533.29. Okay, so that's going to be, this is going to be basically the house price. Okay, 327.533. Okay,
What
So
is
now
down payment?
down payment is just the money you put at the beginning. You want to buy a house, you want to buy a house, you want to buy a car, you want to buy whatever, you go there, bank tell you, okay, I can't give you that, you need to put something down. Okay, you have to put something down. You say, okay, for example, if the car is $10,000, for example, okay, I don't want to share personal information, but I bought my car secondhand for $10,000. Okay, so I went to the bank. I said, okay, I went to the car dealership. I said I want to buy it, buy it, the full thing.
So it's two way of paying the stuff.
Yes. So I went to the bank. I told them I want to buy this car, and I want to buy it right away from without any down payment. Bank said no, you can't do that. You have to pay at least half as a down payment. So I pay half, like $5,000 at the beginning, and the rest of the $5,000 I'm paying like 300 something in a month for 24 months. Okay, that's the story of my car. So that's the same thing for the house, for everything. You have to pay something down because bank doesn't accept. Bank is risky, right? So it's risky. If you do everything from the beginning, you don't pay anything down, it's risk for the bank, right? So the bank is loaning you the money.
Yes.
So the bank doesn't want to do that risk. You have to pay something down, so as a source of security. Okay.
Yes.
So $24,000 is going to be a down payment at the beginning of the house price. You pay So the house price is 327 something. You pay $24,000 as down as a beginning, and then the rest as an annuity. Yeah. Yeah.
Yes.
So that's going to be 327,000. Okay. So now we want to know how much interest he paid. Okay, how much interest he paid. So interest he paid is basically you have to calculate how much he paid at all, right? So he paid 24,000 plus 1,380 for 30 years for every month, right? So it's going to be okay. So let's before we calculate the interest, let's first do it in the financial calculator. Calculate the whole thing in financial calculator, then we go for interest. Okay, so how do we do it in financial calculator? Easy. So you have we need to find present value for this annuity. Okay, the annuity is 1,380 every month for 30 years and interest rate of 3.6% compounded monthly. Okay, so let's do it in financial calculator. 1,380. So let's clear everything again, clear everything again, clear everything again. So everything's clear right now. Second clear TVM is going to clear you everything you have here. Okay. So now 1,380 is a monthly, 1,380 is payment, right? Every month for 30 years, and 3.6% compounded monthly, 3.6% compounded monthly. Now we want to know N, which is going to be 30 years multiplied by 12, right? 30 multiplied by 12, 360, right? So it's 30 years multiplied by 12 months, right? So number of years multiplied by compounding frequency, number of years, the number of payment per month, per year, right? So 30 by 12 is going to be 360. It's going to be N, right? So N, I, PMT. Now we need to just know what's this. PMT, the compounding frequency is going to be 12, payment per year. Like P or Y is payment per year. How many payment per year you have? 12, right? You set it and then you quit it, right? You set and quit, and now you set everything. Now you want to know what's the present value. CPT present value, 303,000, right? And then you get rid of the negative sign in front of it, and then you add it with 24, right? Plus 24, it's going to be 20. Oops, sorry. I had to add it with 24,000 plus 24,000. That's even, oh my God, 24,000 equal to 327,000, right? 327,000. Yeah, in financial calculator. Yeah. All right. So what was the total amount paid over the 30 years to settle the mortgage, and how much of this was interest? Okay. So how much? The total amount he paid over 30 years. How much he paid over 30 years? 1,380 multiplied by 12 multiplied by 30, right? So 1,380 multiply every month, multiply by number of years, right? So it's going to be 1380 multiplied by 360, or 1380 multiplied by n, which n is going to be m multiplied by t, right? 1380 multiplied by n, total number of payment, right? So $496,000 he paid for for the house, and if you deduct it from the present value, you will have this interest, right? So his annuity is basically his annuity. He paid that much money toward $303,000, right? So this is the interest he paid after 30 years of 3.6% interest. Yeah.
But should he be the one pay the interest? Just
Yes, because he's borrowing, right?
yeah. That's the part that I need to ask. So
yes, he's borrowing, right? If he's
not
borrowing,
just okay. Yeah. Sorry for interrupting.
Yeah, if he's borrowing, he has to pay interest. If he's investing, he's receiving interest. Yeah.
Yes.
Yes. If he's borrowing, then you need to calculate the present value, right? So you want to know, you want to know how much you borrowed at the beginning. But if he's investing, you need to calculate the future value, because you want to know how much he earned, how much interest.
Right.
Yeah. You always want to.
Is,
yeah. Go ahead. Yeah. Go ahead.
The interest is for. It's not for the car company. It's for where he borrowed the money from.
That's right. The interest. So generally, the car, for example, for my case, I went to car dealership. He sold me the car, but he referred me to a basically loaner, right? So for someone who loaned the money, it was a private company. If I go to the bank, definitely I would get less interest rate. But I didn't go to the bank because they work for that loan basically there's some private investor that they rip you off. So I didn't have any choice. I was basically I didn't have any choice, so I went with them. So, but definitely, if I go to bank, I would get less interest. But definitely, there's a financial institution that give you that money, and they charge you some interest. So,
yeah, that's how they make money.
That's how we make money in this country. Yeah, yeah, for sure. The banks are always like that. That's how you make money. And the fascinating part is that if you let's do the future. Let's suppose that you don't buy a house, and then you just save this money in your saving account. Okay, you put this money. You presume that you didn't buy a house, but you save this money in your saving account, and see how much money you earn after 30 years. Okay, let's
then
that.
you have to wait until wait for 10 years to buy a car.
Yeah, you have to wait for 30 years.
Yes, for getting
1380 every month 3.6. Let's calculate this in financial calculator. How much money you get instead of buying this property for $303,000 at the beginning, and then pay for a mortgage. You just save this money for 30 years. Let's see how much money you get after that. Okay, let's do that. Okay, so present value in this case is going to be 0. It's the present value. The rest of the thing is going to be the same. So future value is going to be this. $1 million, right? $1 million. After 30 years, you're going to have $1 million instead of this $303,000 that you clear your house with. You're going to have $1 million, right? Almost $900,000, right? You're going to have 3 times of this. 3.6% interest rate. So you're gonna have 3 times of this, of the amount of the house. It's really appealing, right? It's really encouraging that you just save money every month with this interest rate.
Yeah.
Rather than buying a house. Yeah, it's incredible, huh? Anyway, that's very interesting, actually. Wow. Anyway, so that's very tempting, actually. I'm thinking about to buy a house, but now it's just with this calculation is look to me is just better to just save the money and get the interest on it. So anyway, so okay, so let's go to the next example. How much should Bar Steel Incorporation invest in a fund to be able to withdraw 15,000 at the end of every 3 months for 5 years? Okay. So he wants this company wants to invest a fund. Okay, you want to put the money there, but want to withdraw the money. Okay, so want to put the money first at the beginning, but he wants to withdraw the money. Okay, and ask how much has to pay at the first place. Okay, so it's very similar to car loan, very similar to mortgage, right? You want to put money in the bank and then want to withdraw the money every 3 months. Okay, for 5 years, right? So it's going to be present value problem, not the future value problem. Just make sure you understand the question properly. Okay, so you want to put the money at the first place and then you withdraw from it every 3 months. Okay, the money is in the fund is expected to grow at 4.4% compound quarterly for the first 2 years and 6.2% compound quarterly for the next 3 years. Now this is more complicated, right? So you have two annuity now, and two present value for annuity is going to come to the first original investment. Okay, so you have this is the most very complicated question, but you just need to analyze it better. Okay, so you have two annuity. First annuity is going to be for 2 years for this component, this basically compound quarterly, but you pay $15,000 every 3 months. Okay, you pay $15,000 every 3 months. Okay, so we withdraw $15,000 every 3 months. Okay, the same as payment. Okay, you withdraw every 3 months. Okay, so you put the money at the beginning, and now this money grow, and then you withdraw from it for 2 years, and after that withdraw from it for 5 years. The difference between these two schemes is just the interest rate. The interest rate is different from the first 2 years, and the interest rate is different from the next 3 years. Okay, so just the interest rate is different, but the payments are the same, and the annuity is the same. Okay, so now we have the problem of present value. We want to find what's the present value, how much they deposited at the first place, and now they want to withdraw from it. Okay, so first of all, we have two different schemes, right? So the first scheme is as I said, it's 4.4% compound quarterly every 3 months, and the second scheme is going to be a 6.2% compound quarterly. Okay, so we have two present value. So for this guy, we have a present value. We call it present value 2. For this guy, also we have present value 1. Okay, but the problem is the present value 2 is finished here, right? So it's not finishing here at 0 time. The present value 2 for the second basically for second annuity, the present value 2 finished at the end of 2 years, not finishing at 0. Okay, so at the beginning of the 2 years, we'll have present value 2. Okay, so now we have another problem. So we have to basically port this present value to 0 times 0. Okay, so this question is complicated, guys. I'm not expecting you to solve it right away, but just keep in mind that we can look at it this way. Okay, we can just don't look at the first part. We just look at from 2 years to 5 years. Okay, from 2 years to 5 years, he's paying $15,000 for 6.2% compound quality. We want to know how much money he borrowed at beginning of 2 years to clear this loan. Okay, to clear the loan after 5 years. Okay, that's how much money. That's PV2. Okay, the PV2 is the money he borrowed to clear from 2 years to 5 years loan. Okay, and now we want to know how much money was at the beginning of the time, so that it accumulate interest to become to PV2. Okay, so these are two different things. This is a regular investment, regular investment, and this is that's another annuity. So from 0 to 2 years, we have an annuity, with the present value, and also we have another part of the money which grows to become PV2, okay, which is future value 3. So we have two present value. One present value come from this annuity from 2 years, and the other present value come from the future value of the investment which we made for the second annuity. Okay, so PV1 plus PV3 is going to be your final answer. Okay, so let's do one by one. Let's do the present value 1, and then let's do present value 2. Okay, so for present value 1, we have 4 payment multiplied 2 years, which is going to be 8 quarterly payment. Okay, so 8 quarterly payment. You have 8 quarterly payment. You have I is going to be J divided by M, so 0.001. So you have this thing, and you can use the equation P to find the PV1. PV1 is going to be PMT 1 minus 1 plus I power minus N power divided by I. So you find the PV1. So for second part, you have 4 payment, which is going to be compounding frequency multiplied 3 years. And you have from 2 years to 5 years, right? 3 years. So, and then it's going to be 12, and I is going to be 6.2 divided by 4. It's going to be 0.0155, right? So that's going to be for the second part, okay? So for PV1, we have this equation. So we go through equation and solve this using the financial calculator. So I'm not going to go through that again because we already did a couple of these guys. So PV1 114,000. Okay. So for the first scheme, so PV1, what does PV1 is? PV1 is this one, the first from 0 to 2 years. Okay. So present value for this annuity for first 2 years, present value is $114,000. Okay. So if you put $114,000 at the beginning, you can get the money, withdraw the money, $15,000 every month for 2 years, every 3 months, and after 2 years, that $114,000 is going to be cleared. Okay, so that's the first part of the question. Okay, second part is going to be how much was PV, how much PV2. Okay, what's a PV2? PV2 is basically from 2 years to 5 years, for 3 years. For 3 years, he withdraw $15,000 with this N, with this I. Okay, so then we will find what the present value 2 is. Okay, so present value 2 is going to be 163,000. So it means that he needs to borrow, he needs to put $163,000 at the beginning of second year in the bank to be able to withdraw $15,000 for 3 years, okay, to clear it out. So at the beginning of the second year, he need to put $163,000 in the bank, okay? But we want to know how much he put at 0. And we want to know how much he put at this time, so that at beginning of second year he will have $163,000, right? We want to know how much he put at 0 time, so that at beginning of the second year he's gonna have $163,000. So this is gonna be future value, right? So it's gonna be future value after 2 years. So this is gonna be PV3, right? So it's gonna be present value. What's gonna be present value, so that I can put in the bank for 2 years, so that I'm gonna have this money, $163,000, right? So that's going to be ordinary simple, investment, which we use the simple investment formulation, right? So simple investment for formulation is going to be PV3 is going to be FV3 1 plus I power minus N, right? And then use this, we find this value. So that's going to be present value 3. So he has to put 149,436 at 0 time, so that after 2 years he will get $163,000, and then you use 3 years of annuity for second annuity, right? So 3 years of annuity for 6.2% compounded quarterly, every 3 months, he had to withdraw $15,000 from this amount to clear this, to clear this, right? So he has to put basically this amount at 0 times so that he get 163,000, and then use that annuity, second annuity, to clear it. Okay. So now the total is going to be 263,707.55. So to be able to withdraw $15,000 at the end of every 3 months for 5 years, Bar still need to invest 263,707 today. Okay. Do you understand this? Let me go through this again. Yeah, go ahead. Yeah, good.
So
Yeah,
so if the rate of interest changed,
yes.
it would be another different annuity.
Yes, definitely. So if your rate of interest change, if your payment amount is changed, if your compounding frequency change, if your period change, if anything change, you're gonna have different annuity. Okay, and then you have different annuity, you have to use your equation for that annuity. Okay, the tricky part of this question is that for this annuity you have PV2, but this PV2, you can't just add this PV2 with PV1, right? You can't add this PV2 because this PV2 happens after 2 years of money in the bank. You know,
yes.
The money was in the bank. After 2 years, the PV2 happens, right? So you can't just add this PV2 with this PV1. So one straightforward thinking is that, okay, so I have 2 annuity, I have this annuity, I want PV1, I have this annuity, I have PV2, I add them together. Okay. This is wrong answer. Why? Because this PV2 is the money is in the bank for 2 years, then this become PV2. You need to find how much money was in the bank at the first place, PV3, to have this PV2, which is FV3, right? So PV2 and FV3 are the same. So this is future value after 2 years of having which money was in the bank, so that when after 2 years become PV2. So it was a PV3. So this PV2 become future value for that PV3, and this is just a simple investment. There's no annuity. Just a chunk of money. It was a chunk of money which left in the bank for 2 years, and then after 2 years, you pay annuity to clear it out. Yeah, you understand this?
Yes.
All right, guys, you understand this question? This is a little bit complicated question, but I tried to basically explain it as best as I can. So I hope you guys understand this. Right? Okay, so we can do this in financial calculator way as well, right? So let's do it in financial calculator way. Okay, so we want to find PV1, then we want to find PV2. So first PV1. Okay, PV1 is $15,000 every 3 months, right? So $15,000. So let's clear everything here. So $15,000 every 3 months. So $15,000 is going to be. I'll put the negative sign here. PMT. And then every 3 months, which means the compounding frequency is going to be 4. Yeah, and then 4.4% is going to be compounding. Going to be, oh, sorry. 4 set, and then I have to quit this mode. Then 4.4% is going to be compounding frequency, basically interest rate, nominal interest rate. And then what's going to be the N for the first part? 2 years multiplied by 4, right? 4, 2, 4, 4, 8. 8 is going to be N, right? So 8 payment of over 2 years, right? So 8 payment, yeah. So I have N now, I have I over Y, I have PMT, make sure the future value is 0. And then I want to know what's the PV. So 114,000. So this is PV1, right? 114,000, okay? So PV1 is 114,000, okay? So I basically get rid of the PV in front of it and store it in 1, okay? I store it in 1. So PV1 is stored in 1. And now what's the PV2? PV2 is basically again that's $15,000. So $15,000 payment with negative sign here. And then the rest is going to be the same, right? I over Y is 4.4. And N is going to be N is not the same. N is 2 years multiplied by 4, right? So 12. 12 is going to be N. So N, the N I said is future value for this is going to be also 0. 0 is going to be future value. And then the number of compounding frequency is going to be also 4 because it's compounded quarterly. Now I calculate present value for the second one. So PV2 is going to be 163. Okay. So this is going to be I'm going to store at 2. Okay. So for PV2, I need to know present value, right? For PV2, this PV2 basically is a future value for PV3, right? So this is a future value. We want to know what's the present value for this. So I put this as a future value, yeah, and then I get rid of PMT. PMT is 0, and now what's my interest for? I'm talking about this guy. I'm talking about last part, right? I'm talking about last part. So for first 2 years. First 2 years, I want to know I have a future value, 163,000, right? So I recall number 2. That's going to be my future value, right? That's future value. 0 is PMT because it's regular investment. I don't have any annuity. I'm moving basically the FV3 or PV2 to basically current time, to 0 time. So it's 2 years. So it's going to be 8.
But future value isn't 163,104?
Future value is 163.04. Yes. Did I say something else?
I think yeah, it's
Oh yeah. So maybe I made something wrong here. So let's see. All right.
Yeah.
All right. So let's do it again.
Yeah.
Thank you for reminding me. So let's do it again. So I cleared everything now. Okay. So let's do it again. Okay. All right. So all right. So oh yeah, I put 6. Instead of putting 4.4, I put 6. Instead of putting 6.2, I put 4.4. Okay, sorry. So okay, so let's do it again. So we have $15,000 payment. $15,000. I put the negative on payment. 0 is future value. You want to know what's the present value, right? What's 6.2 compounded quarterly? 6.2 compounded quarterly, which is 4. 4 set, yeah. And then you know what's N. N for the second part. So 3 years by 4, 12. 12 is going to be N. And now everything's set. Now I want to know what's the present value. 163,104. Okay, store number 2. Okay, you're right. So sorry. Yeah, I didn't set this right. I over Y, I put 4.4. It has to be 6.2. Okay, so now it's this, and now I will get rid of that and store it on 2, and now I will clear everything again, clear everything again, and clear everything again. Okay, so now everything's cleared now. So now I recall number 2. That's going to be my future value, right? So future value is going to be this, and then it's over 2 years, right? I want to move the money from 2 years, 2 years to 0 years. 0 is 2 to 0, right? So that's going to be 0. That's going to be a future value, 2 to 0. So, and that's a regular investment. There is no payment. There's no annuity. 0 is a payment. And then I over Y, for the first 2 years, I over Y is 4.4%, right? 4.4% for the first 2 years. And the first 2 years, I have 8 as N, right? So 4 multiplied by 2 years, 4 compounding frequency. And then compounding frequency is going to be 4 again, set, quit. So everything's set. Now I just need to know what's the present value. And then get rid of the negative sign. So 149,436. Yeah, 436. That's present value. And then I add this present value with the present value which I had before. So I store this at number 3, and then recall number 1, which is present value of first, plus recall number 3 equal to this 263,000. Okay. Yeah. Any question, guys? Any question?
No, I think it's clear. Thank
Yeah, that was the most complicated question. If you understand this question and you understand the solution for this question, I think you're ready for your test too. I would say in 3 weeks, but but yeah. So that's basically it. So okay. So next week we're gonna discuss other annuity. We're gonna discuss ordinary general, do simple, and do general annuity. And also we're going to discuss the equation for it, and we're going to solve some example for it, guys. So I think for this week, in syllabus they said we're going to discuss ordinary general, but I think it's too heavy for you guys. Just solving some question on ordinary simple annuity, I think for you guys is enough. Enough for you guys to do it this week. I think it's ordinary general. It's going to be a little bit more complicated to do that. So I leave it like this so that you guys practice a little bit in ordinary simple annuity, and after you get familiar with that, you can basically we go for ordinary general. So yeah, any question, guys? All right, one more time. I just want to emphasize that you take care of the labs. Make sure the labs labs and lessons are due. Don't miss the labs and lessons. And if you have any question regarding technical issues with your labs and lessons, please ask Vereta support. That's it. So if you don't have any question, we can call it off today.
Actually, I have a question.
Yeah.
For a question in mock test practice, I use the calculator for calculating dates.
Yeah.
But as the date was, I think it was showing the wrong days between the date. So the date one was 28 October 2014.
Uh-huh.
And date 2, I have to find, I think 4 March 2016.
Okay. Okay.
And
so yeah,
yeah,
calculator is the best. Calculator is the best method. Yeah. Yeah. Okay.
Yeah, but calculator was not showing the right number of days, I guess. So.
Or you entered it wrong, though, right? It's just you can't say calculator was wrong. I'm right. So that's a big claim.
I actually I checked it on the calculator on my mobile phone, and it was showing 127 days, which was shown by the equation as well.
127 days.
Between the dates 127.
Okay.
Yeah.
Yeah.
So I'm confused that what I have done wrong.
Okay, you need to do it in calculator again and make sure if it's different year, that definitely is going to be more than 127 days, right? So if it's like 2004 and 2010, it's like 6 years, right? It's going to be at least 2000 days, right? So 127 days means it's only 1 year, less than 1 year, like is like 3 months, right? So probably the year, you put the year wrong in the calculator.
Yeah, I think so. I'll do it once again.
All right, sounds good.
Thank
All right,
you.
no problem. All right, guys. Okay. Any more questions, guys? All right, so we're gonna call it off today, and see you guys next week. Have a good weekend, guys. All right. Yeah, bye.